Thanks for everyone for being here and joining me today. So like Lars mentioned, I'm going to show you how data engineers can utilize their skills by transforming data warehouse to their very own machine learning lab with bare minimum machine learning skills. Yes, that's possible. About me, you already know that. I'm Nadia, Senior Consultant at Mechanical Rock with a couple of certificates, and I'm also a member of AWS Community Builder. Content I'm going to cover, I will start with delving into the integration between modern data warehouse and machine learning. Following that, I will discuss why do we need to implement machine learning inside a data warehouse. I will showcase 4 different ways that you can implement a customer churn solution in Redshift using Redshift ML. And finally, if you are using other cloud service providers, don't worry about that. I have some suggestions for you as well. We all know AI adoption is not that simple. Most of the teams are only able to utilize AI for a tiny fraction of their data because implementing machine learning and AI in a scale is really challenging. Most of the enterprises are not able to get machine learning based analytics from their data because they don't have a mature data strategy. Modern data warehouse is one of those. We all know that a modern data warehouse collects the data from so many different resources, collects it, and make that one available for machine learning and AI. It accelerates companies' data maturity journey. It's like an AI catalyst, but I'm not here to tell you that we all need to set up a data warehouse. Why do we need to implement a machine learning inside the data warehouse? What's the benefit of that? Before jumping to that, I want to go through some of the challenges we might face if we run a machine learning project. Assume that you are a machine learning engineer and you want to start a machine learning project. What's the first step you do? You extract much of your data from data warehouse and store it in another location. This is a very common approach. That results in data fragmentation and movement of data, duplication of data from one storage to another storage to make that data available for your data science toolkit and train the model based on that data. What else? You need to have really large scale and computational power to download and install all the Python libraries that you require and process a vast volume of data. For that, you need to have computational power. What else? Machine learning needs data. We all know that. We can train the most accurate model if we throw a lot of data, different type of data, to provide to our model to learn from. And finally, for someone who has different skill set, if they want to start machine learning project, they need to skill up. They need to have some expertise. You need to know different frameworks, machine learning libraries. You need to know some services, programming languages such as R. All of this is time consuming, right? What if I tell you, with simple SQL query, you can train model inside your data warehouse? With implementing machine learning inside data warehouse, we are solving that data movement because data sits where it belongs to, and we bring machine learning inside data warehouse, and instantly, real time, we make that one available for our models. Most of the modern data warehouses has the most powerful computational resources. So you shouldn't be worried about that computational resource, how to configure it, and what if your project grows. Machine learning needs data. Your data warehouse is the house of your data, so you can make it available instantly for your machine learning project. Is it fair to say all of this, solving this, is make the machine learning and data warehouse is a good combination? Let's see an example. When we come to a modern data warehouse, we have hands full of options, especially these days. But I'm an AWS Community Builder, so I work with AWS day-to-day job. I would like to focus on Redshift. I know. When we initially started using Redshift, it was costly, and also it was really time-consuming because the standard approach to set up the Redshift data warehouse, it was setting up clusters. It was a nightmare. But Redshift serverless has taken care of all of those heavy lifting. It's a serverless solution. With a couple of clicks, you can create your data warehouse and run it. Believe me, I did it. It's just creating a namespace, work group, and secure it in a VPC and security groups that you have. That's all. It's a serverless solution, so it has two key factors. First of all, it automates scaling up and down when you have unpredictable workload. And also, it helps you to stay in budget. If your data warehouse is in idle mode, you're not going to get charged for that. It helps you to stay on budget with that. With considering only these two features, it makes it a great candidate to implement machine learning inside it. To do that, we have Redshift ML. Redshift ML is a feature set for implementing machine learning inside Redshift. Very simple. It automates processing data and training, deploying, and creating models straight away. It securely integrates with other services that you require for training. Redshift as your data source, SageMaker for training model. For those who doesn't know what SageMaker is, a fully managed service. It automates and you can implement each stage of your machine learning workflow inside SageMaker, from data cleaning, data processing, up to hosting your model, all the steps. So, in the standard approach, you don't need to have a single endpoint to host your model and get predictions from. This is an advantage because it helps you also save cost. You're not managing other separate computational resources to host your model, make it available for your application to get prediction. So, that's convenient. And the key point, you're not moving the data around anymore. Your data sits in Redshift and you bring machine learning inside it. And also, you don't need to have any experience or expertise because it's a SQL-based query language or solution. All you need to know is your familiar skill, which is SQL or SQL. And finally, in terms of cost, when you train the model, only training period is the cost that you will have. For prediction, because you are using the computational resources of your Redshift, you're not going to charge any extra. Enough of theories, it's a demo time, but before that, I would like to go over some of the terminologies in case you're not familiar with before presenting the demonstration. Training. Training in Redshift ML is when you run your create model command and you load a subset of data or even all of your data to train the model based on that. And it's a create model command, which is SQL. Inference is a very common terminology in machine learning. It's when you use your model to get predictions and insight from that model. We have local inference. It refers to when you have a pre-trained model and you want to import that model in your Redshift to get predictions from the existing model. Whereas remote inference is referred to when you have an endpoint, such as SageMaker endpoint, that hosted that model. You want to import that and get remote inference from that model. Enough of theories, fun time. It's the demo time. So I'm going to demonstrate 4 different ways you can implement a customer churn solution. Customer churn, what is that? Does anyone know what's the customer churn? Okay, I'll go ahead. Customer churn is mean that we want to predict if a customer, a client will leave a business or not. And why I've chosen that is easy to follow, is a little bit fun. And I believe for each sort of business that you're running, doesn't matter what sort of size is that and what's the nature of the business, is always important to identify and target those unhappy customers to make them stay in your business before it gets too late. If you have happy customers, not only you can keep them in the business, you can bring more customers into the business as well. And what's the use case of this model in a specific case? So when you have the model, you can get predictions from that, and then you can get that output to a dashboard. You can have alarms in that dashboard. And in case of any threshold pass, you can just trigger, have some campaigns, and target those customers to stay in your business. Losing customer is costly. I've done some setup before going through the slides for the demonstration. So I'm using Redshift serverless because it was convenient and it's very quick to set up. I didn't have data in my data warehouse, so I'm using a public data set, which is a bank customer information. It shows if customers has churned the bank or not. I've set up a role, which is an IAM role in AWS, has enough permission to have access to those data. And also it's trusted to Redshift and SageMaker, to both of those assume that role and do the training process. That's pretty much it. But all the codes that I'm going to show you, don't forget, all of those are available in a GitHub repository, and I'm going to share that repo with you as well. To begin with, I just simply go to AWS console and search for Redshift. It brings the Amazon Redshift. I have done the setup, so I start inspecting my data. I usually do that, especially if it's a data set that I'm not familiar with. This data set, it has a big feature set, but I can identify column Y, which is yes or no. It shows that if those customer has left the bank or not. I mentioned earlier, Redshift ML is a SQL-based query language and solution. I see all of you are trying to read this command. It's huge, complex, don't worry about that. I'm going to break it down for you and explain. You don't need to know every single parameter of this huge and complex command. This is a very complex but flexible command. Depends on your experience, whether you are a beginner or you're already a machine learning expert, you can play with different parameters and train the model in the way that you are comfortable with. I personally, to understand it, split this command to 3 different sections. I start with data, because I specify create model from my data. That data could be your table, entire table, or you can have the most complex selected statement from 1,000 different tables and train the model based on that. Second section is the model. You can specify what you are training in this section. If you're already a machine learning expert, if you already know how to train the model, what sort of algorithm type is that, what sort of hyperparameter that algorithm has, and what sort of evaluation metrics you require, you can set all of those in this section. And we have a configuration, which is the setting of your command. You can improve the security of your data when you are training the model. You can specify how long you want to run this training job. But amongst all of these parameters that you're seeing, there is one specific parameter that specifies how you want to train your model. Do you want to be in auto on or off? But what does that mean? I will explain shortly. But let's start with the very simple way and train our very first model with auto on, which by default, Redshift ML is on auto on. What happens under the hood when you run your create model command on auto on? Redshift extract your data and make it available for Amazon SageMaker Autopilot. What is Amazon SageMaker Autopilot? It's a feature set of SageMaker. All it needs is data. You don't need to have any machine learning background. You just pass that data to Autopilot. Autopilot goes, reads that data, understands the data, find out what sort of problem it's trying to solve, finds the best algorithm that matches to your problem. Then, when it does all the data processing, feature engineering, it trains multiple training jobs to find the best model. When that model is available, SageMaker now will optimize it and import it as a SQL function to your Redshift. What is that SQL function? It's your actual model. That's how you get prediction from the model you just trained. Let's look at the syntax in AutoOn. I told you, if you're using Autopilot, you don't need to go down all that complex command. All you need to specify is your data section. What you specify? You set from what data you are running that create model command on. And this is a supervised learning. You specify your target column. This is the data or column that your model will learn from. This is an example in your data. And we specify function name. When you finish the training model, the model will be available under this function name, and you can get prediction from it. We also specify our S3 bucket, which is the garbage for Redshift and SageMaker. Here's an example of the customer churn model. I specified my entire data. I specified column Y, which was my example in my data, and also my function name. Obviously, settings as well. I simply run it. By running that, the training job will be started. There are two specific commands which is really useful when you're running a training job. One of those is show model. Show model gives you a lot of information about the model which is under training. It tells you when the training is done or it's still in training mode. There is another useful parameter here, which is the model type. Because we are using auto on, the model type is auto, because Autopilot is going to pick that model for us. We have not specified what sort of model we are training. In addition to that, because in this example we are using Autopilot, it gives us the name of the experimental task that has created in Autopilot. You don't need to go down to the detail what happens underneath like after this, but I will show you quickly. So if I switch to Autopilot, I will see a new job has been created and is in progress. But what that job does for us, if I go to SageMaker, I will see under hyperparameter tuning job, there is a job created, which is the hyperparameter tuning job. With this job, that's where we're running a lot of multiple training jobs to find the best model. Where are those? Under SageMaker training job, we will see a lot of training jobs has already instantiated. Once this is finished, we can see our Autopilot task, experimental task is completed. And our model is ready. The cost for training was only $11 USD. It's not that expensive for 1.5 hours. So it's not that costly then. Prediction time. It's the fun time to see how our model do. For prediction, you guys know that. It's just a SQL function. All you need to have is the SQL function and all the parameters that it requires to get prediction. As simple as that. And then you can get predictions. But I don't want to go into that, like down to the machine learning concepts. But here I think that it's good to explain the confusion metrics. The model that we are training is a binary classification. We are saying if customer churn or not. For binary classification, when you want to evaluate the model and find out the error rate, we always care about false negative or false positive. In our case, we want to reduce the false positive. What that means? If we consider this one as our predicted result, and this is the actual result that we get, this is the false negative. That means our model predicted the wrong value. It said the customers will stay in our business, but in reality, they're gone. If we use this model, it means that we are losing about 254 customers to target. It's not a bad model, it still is a good accuracy, but we could improve the quality and accuracy of this model with running the job for a longer period. Or Autopilot needs data. If your data set is cleaner, you are passing less feature set into your Autopilot job, you will get more accurate models. That was the very simple when you don't know anything about models and machine learning. What if you're already an expert and you want to train your model inside your data warehouse using Redshift ML? When you use your create model, this time we set the auto to off. We say that, hey Autopilot, thank you, we don't need you. We want to train the model in the way that we want. So this time Redshift, we export the data, make it available this time. We are not using Autopilot. It will be SageMaker itself. When you run create model, it creates that model in SageMaker. Training job will be run in SageMaker. And then when your model is ready, again, we ask Neo to optimize the model and import it as a SQL function inside Redshift. Syntax seems to be a little bit complex. You feel like, oh, okay, I'm running all the command. But all you need to set is that auto should be set to off. And then we specify the ML, the model section as well, because Redshift now doesn't have that smart of Autopilot anymore, and we need to specify to Redshift ML what we are training. In an example of customer churn, I have set the auto to off, and I know that customer churn is a binary classification. XGBoost is a good algorithm for that, so I set it to that. I know objectives or the evaluation metrics to evaluate the accuracy of model during training. Binary logistic is one of those. And I have override some of the hyperparameters as well. As simple as that. I trained the model. So this time, because we have specified the parameter of a model type, it tells us that the model type is XGBoost. And also, instead of showing a job in Autopilot, we have the training job in SageMaker. If we go to SageMaker, we will see a new job has been instantiated as it's in progress. Once this job is finished, we can get prediction from the model. Same we did for the previous approach, which was the simple one. We just pass the name of the function with a bunch of features and parameters that function expect to receive. This time model did better, but bear with me. I'm not saying this approach is better than previous one. I told you, you could improve the quality of the previous model and just pass cleaner data or run your job not 1.5 hours for 4 hours. As simple as that. And also for this one, I have already done all the hyperparameters. So we could do the same thing with the previous model. Although we are using in auto-on, we can still contribute with the training process. We can tell Autopilot what sort of algorithm you want to use, what sort of hyperparameter to override. You can have that flexibility as well. These two approaches is when you want to train the model inside Redshift. What if your data scientist team already has a model and you want to use that one in Redshift? That is also possible. Redshift ML supports bring your own model. So local inference is one of those. If you already have a pre-existing model and you want to import it in Redshift to get real-time instant inference from your data, you can do that by simply passing the job name inside your create model. This time there is no training involved. You just import that model, localize it in your Redshift to get prediction. Simple. But again, you need to optimize it because the model has been trained outside. There is a model. We optimize it, import it as SQL function. Syntax is very simple and similar to the first one. But this time, instead of passing and creating the model from data, we create the model from existing model or a job, training job that we have the name of it. There is a small change here as well. This time, if we run describe model, Redshift is not able to describe the model for us because it hasn't trained the model itself. So we need to specify the return type and what sort of parameter it requires to receive. For our customer churn model, I have a model I don't reveal, but it's not a good model. We will see how it predicts. So I have the training job name. I have specified that one in my command. And then in my function, it's just function name and all the inputs that I know I'm going to pass this for prediction. And the return type is XGBoost. It's a binary classification. It will be an integer. That's it. When I run it, this time there are a few parameters that are different. One of those is that inference type. In previous two approach, we did not have that one because we were training the model inside Redshift. But this time, because we are importing the model, it tells us, hey, I'm locally inference. I have my model type is local type. That's it. So for prediction, again, same as previous one, nothing magical will happen unless my model doesn't do very well. This is not a good model. I have not done any tuning on this model. It's just a simple model, has gone through the data and has learned some stuff. But if we use this model, we will lose about 4,000 and almost 700 customers. So not recommended. But this was that easy approach, right? And when you run this command, it will take only a couple of minutes to import that model inside your Redshift, and it's available for you instantly to get inference from it. Final approach is the remote inference. Is the time that you already have a model has been hosted in SageMaker endpoint. You have some application that are using that endpoint to get inference from. So what happens under the hood in that case? All you need to specify in your command is your SageMaker endpoint. And this time, again, there is no training involved, so less cost, but you have taken care of all of those training outside Redshift. When you run it, it will just find that model or the endpoint and then create a SageMaker SQL function endpoint to get remote inference from that endpoint. Syntax is again very simple because there is not that model section is not included. Less complexity. We specify the function name and return type and our SageMaker endpoint. With running that, we have the model imported inside Redshift. Our customer churn, the previous model which didn't do very well, but for demonstration, I just deployed that model to a SageMaker endpoint, and I already have it running in SageMaker endpoint. I can just invoke the endpoint to get predictions. So I have the SageMaker endpoint, I pass it to my create model command, and then I can get prediction straight away. This is the very quick way to create a model or a SQL function model inside your Redshift, because all the heavy lifting is outside Redshift. You just import it and you have it available. This time also, it tells us from which endpoint we have created the model and also what's the inference type. It is remote. For prediction, I didn't expect any magic happen. It's the same model. It's just like differently I'm invoking and getting prediction. So again, if we use this model, we will lose about 4,700 customers. If you are thinking, okay, where are those models when I can find them? When you go to Redshift in your data warehouse, on the function section, you will see all the models that we trained with 4 different ways. All of those are available under that function section. Fun for other people as well. If you are using other cloud service providers, if you are using other data warehouses, don't worry about that. If you are using Snowflake, a Snowpark ML is an amazing toolkit. You still need to know a little bit of Python because you download some libraries in a Snowflake and it enables you to clean all the data, and then all the training is against SQL base. So when you train the model, that model is available as a user-defined function or you define in your Snowflake. If you are using Google, sorry, don't use Google, come and use AWS. But Google BigQuery is a famous one. It's a very similar solution to Redshift ML. If you find this solution useful, you can implement exactly the same thing in your BigQuery. It's based on Google SQL query language. It's familiar. It's very simple. It also supports bring your own model. So if you have advanced model that's been trained outside, you can import that one and use it. And finally, Azure. A story with Azure is always different. But Azure, if you're using Azure Synapse for your analytics and getting insight from data, it's also compatible with ML libraries or frameworks and also Azure ML. But it's a bit different. You need to have really Python or R skills to train the model. But it's possible. So you can implement machine learning inside that as well. That brings us to the end of this presentation. All the codes example is there in that GitHub repository. For the solutions I couldn't cover, those are really good blog posts or documents. Please refer to that if that's what you're using. Also, the recent announcement from AWS is that now Redshift can mount to the Glue schemas. If you are using Redshift, if you are using Glue, you can mount this together. You don't need to redo those schema inside your Redshift anymore. And final slide is about me again. My email at Nadia Reyhani Mechanical Rock, and also I'm on LinkedIn. Don't forget to connect. Yes, if any question. Thank you.